Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening. We are from Group 4.
A journey of 1,000 miles begins with a single step. So today we want to presenting about 3D printing process of mini crane model.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel Zafran bin Farah Anwar. My matrix number is 01DKM24F1015. I'm from DKM4A. Alright, let me start with a brief introduction to 3D printing. 3D printing, or also known as additive manufacturing, is a process where physical objects are created layer by layer based on a digital design, usually from CAD software, unlike traditional manufacturing methods, which involve cutting or removing material. This process builds the object step by step, which makes it more efficient and flexible. In the field of engineering, this technology is very important. This is because it allows engineers to produce their prototypes in a much shorter time. Instead of waiting for parts to be manufactured, using conventional methods, we can print them directly and test them almost immediately. Besides that, 3D printing also supports functional testing where we can check whether a design actually works as intended. If there are any issue, we can easily modify the design and print it again. This process is what we call iterative development, and it helps improve the overall quality of product. Now, for our project, we chose to design a modular mini crane. The reason we selected a modular design is because it allows each component to be separated, analyzed, and improved individually. This also makes the assembly process easier and more systematic. The crane itself consists of several main components. First, we have the base, which provides stability and support the entire structure. Then, there is a rotating turret, which allows the crane to move horizontally. Next is the crane arm, which extends forwards to carry loads. Finally, we have the hook, which functions as the main part of lifting objects. During the development process, we follow a proper 3D printing workflow. This includes designing the model in CAD software, preparing the file for printing, and carefully setting the printing parameters such as layer height and material selection. By following this workflow, we were able to ensure that all the components have good structural strength, proper, proper fitting, and accurate dimensions. This is important to make sure the final model is not only functional but also reliable. Overall, this project demonstrates how 3D printing can be effectively used in engineering design to develop a working prototype in a systematic and efficient. Let's move on to the objective. The objective of this project are clear. First, we wanted to apply our CAD modeling skills to fabricate a complete mini crane prototype. Second, we aimed to execute the correct digital workflow, starting from CAD design and moving into 3D printing software. Third, we prepare the model for fabrication using slicing software, which is an essential step before printing. Finally, we analyze the functionality of the assembled parts to confirm that the crane could perform a basic mechanical
Assalamualaikum. My name is Muhammad Hafiz bin Muhammad Lutfi. My matrix number is 01DKM24F1086. I'm from DKM4C. Okay, now let's talk about the CAD design. Our design process began with Autodesk Inventor Professional. Each component was modeled individually to ensure dimensional accuracy and proper fitting. The base was designed to provide stability. The turret was created to allow 360-degree rotation. The crane arm was designed for vertical movement, and the hook was modeled to hold loads. By focusing on accuracy and tolerance, we ensured that all parts could be assembled smoothly without misalignment. This stage was crucial because any error in CAD design would affect the printing and assembly process. Let's move to the project goals. After completing the CAD design, the model was exported as an STL file. This format is compatible with slicing software such as Ultimator Cura or Prusa Slicer. The slicing process converts the CAD model into G-code, which contains instructions for the 3D printer. During slicing, we adjust parameters such as layer height, infill density, and print speed. For example, the hook and crane arm require support structure due to their geometry, while the base require higher infill density to provide strength. This adjustment ensured that each part was printed correctly and could function as intended.
Assalamualaikum. My name is Muhammad M. Ahmad bin Muhammad Aswad. My metric number is 01 DKM 24F1 102. I'm from DKM 4C. Now I would like to talk about 3D printer handling. The 3D printer we use is based on FDM technology, which stand for fused depositioning modeling. Before printing, several steps were necessary. First, we perform bed leveling to ensure proper addition of the first layer. Second, we load the filament, which was PLA in our case. Third, we set the correct nozzle and bed temperature to avoid printing error. Proper handling of the printer is very important, not only to achieve good print quality but also to ensure the safety. Since the printer operates at high temperature, we had to be careful during the printing process. Each component of the crane was printed separately. We start with the base because it provides stability for the entire structure. Next, we print the turret, followed by the crane arm, and finally the hook. During the printing process, we face common issues such as warping and layer shifting. Warping happens when the edge of the print lifts from the bed, while layer shifting occur when the layers are misaligned. To minimize this problem, we adjust the temperature setting, reduce the print speed, and use proper support structure. This step help us achieve better print quality and avoid waste. Next is functional movement. After printing, all components were assembled to form the complete mini crane. The design allows functional mechanical movement. The turret can rotate 316 degrees. The crane arm can move vertically up to 100 degrees. And the hook can hold load. This demonstrates how proper design and tolerance contribute to functional mechanical system. Even though the crane is prototype, it shows how additive manufacturing can be used to create working mechanical model.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ivan Zulkifli bin Zulkifli. My metric number is 01 DKM 24F 1082. This project required effective teamwork. Each member was responsible for different tasks, such as CAD design, slicing, printer handling, and assembly. By dividing the work, we were able to complete the project efficiently. Safety was also emphasized throughout the process. We followed proper handling procedures when operating the printer, especially when dealing with hot components. Good communication and coordination among team members ensured that the project was complete without accidents or errors. So, in conclusion, the Minicrim project demonstrates how digital design can be translated into tangible engineering innovation. It reflects creativity, precision, and mastery of additive manufacturing workflows. Looking ahead, we believe that improvements such as enhanced durability, smooth motion, and better material efficiency could transform this prototype into a fully functional mechanical system. This project has given us valuable experience in CAD design, 3D printing, and teamwork.
Okay,
Thank you.
finally, we reached the end of our slide. Once again, thank you for your time and attention. We truly appreciate the opportunity to share our project presentation.
And we believe this project demonstrates our ability to apply engineering knowledge into practice. Thank you for listening to our presentation.